Immediately going to do start recording. Don't ask me why, that's just how things go. All right, hello everyone, welcome to Handmade Hero. The game, well, I was going to say the game, but it's not a game. It's a show where we code a complete game from scratch, live on Twitch, no engine, no libraries, just us and our typing fingers. We are actually pretty far in now, like we've done a lot of stuff. We have gotten to the point where we've kind of got a lot of our prototype stuff working. And we just finished up a pretty major change to how we were we've been sort of working on how we want our engine to be architected. And we just finished up a pretty major change, which is we changed to using these things called update, like simulation regions, which are like basically regions of space that we update together. That solved a bunch of problems for us. So I'm pretty happy with how it went. And we have one more thing to do with them that at least I think is probably something we should do with them. So that's what we're probably going to do today. And then we'll be moving on out of that system into looking at some other stuff. So if you would like to follow along at home and you pre-ordered the game on handmadehero.org, you should have gotten a link in your email, and that link allows you to download the source code anytime you want. So if you take a look here, we're on day 67. So you would unzip day 66's source code into a directory, and then you would be exactly where I am right now. So you could follow along with coding at home, which I highly recommend doing if you can, because it's one of the best ways to learn is to code stuff yourself. So let's go ahead and get started. If I remember correctly, we had pretty much finished up looking at the stuff that we wanted to look at. And we actually already sort of put in a little test of shooting an entity out from our entity. We don't really have any graphics for it or anything yet, but it's essentially just shooting a rock in place of something where we might actually put something, a little plate. And so that was basically all done. And so the only thing that really I want to take a look at was what happens in the apron of our update region, right? And so I'll just go over briefly what that was, just so because people may have forgotten, because we did a bunch of work with the update regions that had nothing to do with this part of it, but I mentioned it kind of briefly, and now would probably be a good time here, day 67, to go to the whiteboard, or I guess in this case blackboard, and draw out sort of what I was talking about. So basically, here's day 67. What I was concerned about, and the reason that I wanted to add one more thing to the simulation region, is we sort of have a couple different scopes in our simulation region usually, right? We've got the area where the camera can see, and we know that we always want to simulate that. And then we've also got surrounding that sort of a wider region, and that is the simulation area, right? So this is the simulation area that we want to actually simulate everything in. And the reason that I wanted that to be bigger than the camera area was just because I would like to be able to simulate people off screen at full speed and have it so that, you know, if they did something, like let's say an AI over here sets a bomb, you would hear it, or it might blow through, you know, like let's say there's a wall here, it might blow through the wall here. We want to be able to support any kind of like rich interactions immediately in the vicinity of the player that might be interesting for them to see or feel the effects of, even though that they're not on screen. What happened, the effects of what happened might sort of be off screen, if that might spill onto screen, if you will. So these are our two areas, but there's another area that I wanted to include, right, which is just one more layer out, right? And this is sort of the collision area. And so what this was about was, if you are simulating everyone in this region, that includes obviously people who are sort of right on the edge of the region, right? There could be people who are sort of right on that edge. And those people may decide that what they want to do, you know, if they're AI driven or whatever, obviously the player is going to be in the camera area, but the AIs are not necessarily. They may just be trying to do things like move outside. They may be moving in the direction that would take them outside of the simulation area. And what I'm afraid of is that if we just allowed the simulation to occur as is, only using this as the boundary of the entities that are pulled in, there may be entities right there that should be stopping them from doing that motion, but those entities will never get seen by the collision detector because the collision detector is only working on the things inside the simulation area. And so what I wanted to do was say that we've got one more sort of boundary that's a little bit wider, and that is basically growing the simulation area by however much the maximum movement speed is per frame, right? You know, if that's 0.01 meters or something, I mean, who knows what it is? Maybe it's 0.1 meters. We'll figure it out, right? Whatever the in 1/30 of a second, how fast can the fastest thing in the world move? or more to the point, we could even do fastest thing in the simulation area if we wanted to. But how fast is that? And then make sure that we make something that big, and that way we will know that we will include in the simulation area anything that might have essentially collided with, with this object, right? So that way it'll stop that bug potentially from happening, which would be a bad bug for us to have. And it's sort of this is not entirely accurate either, because this sort of ignores one thing that we haven't talked about with our spatial partition, which is the size of entities, right? So size of entities is actually also something we need to think about, because what we want to do as well is we want to make sure that we bring in any entities, like let's say that we've got these tile chunks, right? And the tile chunks are the things that we bring in, that we see what tile chunks are within our region. Well, if a particular entity, we're putting entities in the tile chunks based on their center, right? But the entity itself might have some size, right? The entity itself might be fairly large, let's say. I mean, it might not be that large relative to what we're talking about here, but it could be, fairly large, right? And so if something could be fairly large, we also want to make sure that we would include it in here if its total size would cause it to sort of protrude into that area, right? Into the simulation area. Into the collision area. So really what we have is when we grow this area, we actually want to grow it by essentially a distance, both in x and in y, right? To make sure that the band is proper. We want to be able to grow by the radius of the biggest entity, right? And we also want to add to that the speed of the fastest entity, right? And really, we don't need to necessarily do both of these, because it's really when you combine the two. So what we could say is, for all entities, if you took their radius plus their speed, right? We want radius plus speed. We want to basically say the maximum of that. So we want the maximum, whoever's radius plus their speed is the largest, that is the size we want to enlarge our region by. And then we would know that everyone who might be involved in a collision would be sort of grabbed, right? And maybe we add an epsilon here in for safety, like, because it is floating point. Maybe we don't want it to be quite so exact. Maybe we want to make sure that we've got a little bit of a buffer as well, just to make sure that we don't have rounding errors or something that are going to cause some kind of really bad problem. But in general, that's what we want to do, right? And so figuring out that number is not something we need to do now, because we don't even know something like that right now. We haven't defined all of the types of entities that might be in the game. But what we would like to do is make it so that this is supported. And the reason that this is not supported right now is because things in this region, we could easily expand the region and run it. The problem is the things in this region would then get simulated. But we don't want to simulate them, because if we did simulate them, we'd then have to keep on enlarging the region to see what things they could collide with, and so on and so forth, right? So what we really want to do here is we want to say that anything that's inside this region isn't going to get simulated, right? It's not going to get a chance, it's not actually going to get its chance to do its move, whatever its move is, right? Only the things inside the simulation area are going to actually have the opportunity to move. And these things are just going to be brought in sort of as stationary static objects that cannot be moved, but that will serve as colliders for these other things, right? And so that's basically what we would have to do. So this is the one thing, like I was saying before, that I'm not super thrilled about, because it is a little bit, there's a little bit that I don't love about that. It's almost totally fine, but the one part that I don't love about it, just in my head, is what it means is that when two things collide, if one of them is in that static state, then they can't be moved, and whereas normally they would have been able to have been moved. So for example, we could have written collision routines before that would flat out just teleport somebody if we wanted to, and that's not really allowed anymore, right? It could teleport them as long as it was going to teleport them to somewhere inside the simulation area, but it wouldn't be allowed to teleport them anywhere outside necessarily, or other things like this, right? It certainly can't move them to outside this zone. And so it does impose a restriction. I don't know if that restriction would ever actually matter in practice. I can't think of a particular reason why we need to do that. but it is a restriction, whereas almost everything else we've done with the simulation regions has gotten us to a place where almost everything's restriction free and all the code can be written as if it doesn't even care about the simulation region. And that was kind of nice. Whereas that's one thing that does have to kind of be aware of it. And I don't love that part of it. But I'm not sure there's really much else you can do about that. So basically, yeah, everything has to basically have a marker in it which says, which will say whether or not it gets to be simmed in that way. So let's go ahead and add that. Because that's really the thing that I want to do today to finish up those simulation regions. And again, we don't really have to do anything particularly fancy here because we're just doing our engine spec stuff. And you know, we'll have plenty of time further on down the road to think about optimization and you know, sort of other things that are going to impact this as we get more information about how the game plays. But I just want to make sure that the concept's in there so that we kind of are familiar with it, know that it's there, and so that when we make architectural decisions, we're aware of it and not just sort of going blind. So here's the sim entity flags, which are already storing our special states like collides and non-spatial. We have entity flag simming right now, which is basically a thing which says that it's in the sim region. So that's not what that particular thing means. So we also have like an entity flag basically that I want to define here that means the thing that I just described on the blackboard. I'm not sure exactly what we should call it, but probably, I'm guessing, something like can update or you know, updatable, right? I'm not sure what it would be. Can update, we'll say. Now, the thing that's a little bit strange about this, you know, I think I might actually not do that now that I think about it. I think I might not actually do that. What I think I'm going to do is do it slightly differently than that, because the flags are something that gets persisted, and this is not a persistent thing. This is only true inside the sim region itself. So it's kind of like the storage index, which is it's something that, you know, basically, and I should probably put a note here, these are only for the sim region. Once we start separating out this entity type into things that are stored where they should be stored and that sort of stuff, once we start breaking this apart, this is actually something that would go with like just the sim region part of things, right? Whether or not this entity is updatable. And so I think that's probably just a better way to do that. I think that's probably just the right, yeah, that's probably just the right call. So what I'm going to do is I'm going to go ahead and say that things that are updatable are going to get that marker, and then we'll come in here and we'll sort of do the most lightweight thing I can think of to do there, which is that when an entity gets added, right, what I'm going to do is I'm going to say that if that entity is inside a certain rectangle, then it's okay to be updated, right? So the sim region will store inside it, it's got this bounds, right? And then it also will have a new thing, which is basically update bounds, right? Or updatable bounds. And so that's the area where it's actually going to be allowed to, if someone's inside that, they will get like a tick, basically. And if not, then they won't get a tick. So I'm going to go ahead and say that the updatable bounds are in the sim region. I'm going to go ahead in here and check to see every time an entity comes into the active set, I will basically set, when I set its storage index, I will set whether or not it's updatable based on whether it's in those updatable bounds. So I think we've got already, we already wrote the code for this, right? If you remember down in begin sim, we're already doing exactly this operation. We do an is in rectangle, right, like this. And so all we really need to do is we need to do just that is in rectangle where we sort of do the check on the updatable bounds. Now, what I don't remember is I don't remember what we did with mapping the world space. It looks like the world space gets mapped out here in this add entity. And so the only thing that I'm not sure about is basically exactly whether I should update these or not in here. I'm guessing I'll just leave them outside for now. So if you call add entity raw, you're responsible for setting that updatable yourself, and it'll assume that anything that gets added is not an updatable entity otherwise, right? And so assuming that it got added by the call that actually does know the location of the thing, then we will go ahead and set it at that point to be updatable based on the bounds check. So we'll do, oops, updatable, and we'll do dest p, like so. Now, I, again, don't really know if I actually need to do this at this point. I could just do this check when we're actually rolling through and doing updating, and then I wouldn't have to store anything at all. But the only reason I'm not sure about that is because I'm thinking that sometimes we'll want to mark things as updatable that don't necessarily have a position, things like this, if we have synthetic entities or something like that. And so I think I'm just going to leave it as a bool because obviously it's easy to do it that way. And that way we'll be able to quickly set it in the future if we want to. So I'm going to say that that's pretty much the entirety of it. And then when we do our simulation step, right, which we're currently still doing out here in handmade.cpp, we haven't pulled it out yet. When we're doing our simulation step, we're just going to go ahead and check that. And we're going to check to see if this thing is not supposed to be updatable, then we won't actually update it, right? Okay, so how should we do that? It's a little bit problematic at the moment, and the reason it's a little bit problematic is we're still going to want to render it potentially, or maybe we won't. Now that I think about it, no. I guess if something's out in that region, we shouldn't be rendering it either. So really, this entire, I guess it's not janky. It's totally fine. This entire thing should just be skipped, basically for anybody who is not updatable. So we'll just say if the entity is updatable, then it can have its day in the sun, and if it's not, then it's not, and it doesn't get to do anything really at all. And so I think that's about it. What I do have to do now is figure out how big that updatable region is, and or really that's not true. We already know how big that region is. We got to figure out how to enlarge our other region. Because remember, the update region is the region that we're already using. What I'm talking about is expanding it out a little bit. So really the updatable bounds are actually the bounds that get passed in, right? And the sim region bounds are actually going to be those bounds plus some additional size, right? And so for now, like I said, we don't actually know what that size would be. We have no idea. So I guess we'll just say our safety margin, right? Our update safety margin will be something, and we'll put a to-do here that says important, KC, and this is what the to-do we're doing right now, actually. Important, we want to say that this is calculated eventually, calculate this eventually from the maximum value of all entities radius plus their speed, right? And then we will know that we are safe. So for now, we're just adding a meter, but in the future, we should add something totally different than a meter once we actually know what's going down. So we've got that. That should be basically enough now. So all we need to do is be able to, sort of enlarge those bounds. Now, I already told you about the Minkowski sum, right? I sort of was stating before that, I don't know if you guys remember when we talked about collision detection, I was sort of saying that a rectangle plus a rectangle equals another rectangle, right? And the way that you do that is if you imagine these were radiuses of the rectangle, right? So you have like half the width. This is the height over 2. This is the width over 2, right, of these guys. So if this was A and this was B, then this guy is just A plus B, right? So basically adding two rectangles together is pretty darn simple. You just take the center point, and the center point stays the same, and you add, well, that's not, you know what, I shouldn't say that. That's not entirely true, what I just said. Technically, if you were doing a real Minkowski sum, you'd actually add the points without considering the center point. So really what we want to do here is not really a Minkowski sum. What we really are sort of saying here is it is a Minkowski sum, but it's a Minkowski sum with a rectangle that's centered around 0, right? Which is sort of a special case. So yeah, that's sort of, I kind of threw the term around a little loosely, and I shouldn't do that. So really what all we're saying here is whatever the width was of this guy, width and height, right? So if this was width 1 and height 1, and this is height 2, width 2, we just want to add those together so that we end up with something with h1 plus h2 and width 1 plus width 2, right? And so in our case, we know that we want to expand our additive region is just going to be that value, that 1 meter, right? The update safety margin. So all we want to do is take our rectangle and add the safety margin to to all sides of it, basically, right? So in order to do that, I think I might add a thing to our rectangle code that does this automatically, so that I can basically say that, you know, the updatable bounds, if we want to produce the bounds of our sim region, what we're going to do is we're going to do something like a add width height, like something like this. And yeah, so we'll add, I guess, add radius 2 or something like this. And we'll do something where we just say, we'll add that safety margin, and that will go ahead and add it. And maybe we'll allow you to pass in a width and a height radius, essentially, to add to either side. So inside our math routines, we just have to go and add that, which will be really simple. Obviously, we've got sort of our rectangle calls here. All we need is a new rectangle call, right? Where we do add radius 2, and that will take one of our rectangles, the source rectangle, right? I guess we'll just call that A. And then it will take two things. It'll take a radius width and a radius, oops, getting close to my head there, radius height. So again, really, really simple here. All we have to do is you know, do a subtraction and an add. I guess I'll do it this way. From the min and the max of the thing that's passed in, the minimum corner of the rectangle will just get it subtracted, the radius, right? And the maximum corner will just have the radius get added, and that's it. And that should produce for us a new rectangle that's, you know, bigger by that much. All right, so let's go ahead and check that out. There we go. And now I think that should just sort of do it. Again, we don't really have any good ways to test this at this point, but that should just about do that. And of course, we're still doing this here. Yeah. All right. So the last thing that we have to do is we kind of got to figure out how we want to deal with like the sword and stuff. So should the sword still work? Because once we, you know, do we have to make things updatable, or will they just automatically handle that? Let's find out, I guess, was the thing that's probably the easiest way to do it. So inside, where is it here? Where's our sword code? Handmade. I probably should also pull out this stuff into the sim region, since it's pretty much where it's, or maybe into the entity file. So if we go through here and we're doing our hero, and then we're going to go ahead and do the update for the sword, and we do the make entity spatial thing, which moves it into the spatial set, should that gives it a position. So the next time through, you would think that it would get pulled in, right, to the simulation region and get updated. I would think. That seems like what should happen, but let's find out if it's what actually happens. See, I'm not seeing a sword there, so I feel like I'm not thinking it through properly. I'm just trying to figure out whether we need to move things into the update set that aren't, you know, these things are obviously not updatable or whatever. Would be, oh, well, no, never mind. I was just trying to, well, let me check. Let me go ahead and check. So what I just realized is we may never set positions properly on our thing that hoists things in from references, right? When we do load entity reference, what are we doing here? Yeah, okay. See, that's, yeah, so this is actually just a bug. This is just totally a bug. We never saw the bug before, but it was always there. When we load an entity reference in, we should go ahead and get its position set here, right? Because just because we happen to be loading it in via reference doesn't mean we wouldn't want to position it if it had a valid position, right? And so that seems totally bogus to me and not at all like what we would want it to do, right? So we definitely want that, the get sim space p call, we definitely want to do that. So it's sort of starting to feel like, yeah, well, no, because I guess the reason that we did it this way to begin with, right? The reason that we had the get sim space p pulled out is because we needed to do that ahead of time to see whether it was in the update region or not. So I guess we should just keep doing it this way. But what we should do, I think, is just go ahead and do that get sim space p right on the low entity. So we'll do it this way, right? Entity. I think we should just probably make it a fact that we always do this additional call when we're loading the reference so that we know that we'll always actually have that guy in there properly. All right, so we're going to do the get low entity, game state ref index. We will, actually this is low entity, we will get simspace p on him, and we will go ahead and pass that to this call, like so. And there we go. That's about it. And also, does add entity, I don't even know where this is actually getting called now. I guess it gets called only when someone actually does have that simspace p, so it's a little bit weird. Yeah, it's a little bit weird, and we just did that to do as well. So let's take a look. I feel like that could be simplified a little bit. I feel like we've got a little bit more than we need now in terms of stuff, but who knows? It's not that much, so we'll see. All right, so there's that. So that's fixed, and that's what we would expect now. And I think everything's pretty good now. I think we're pretty happy with that. I don't think we need to do too much else. So yeah, where are we on time? We still have a half an hour left. So I think maybe what we should start doing now is start actually going back and looking at the stuff that originally motivated this sort of things, which is just having hit points, being able to do some stuff with that. Having trouble getting the water in my mouth today. That's not good at all. You'd think that after a while, I'd be good enough drinking from these things that I wouldn't have that problem, but you know, it's not true at all. Absolutely disastrous here. The problem is, of course, I suppose it's not almond milk. I was drinking water from this today, and so, you know, at that point, the viscosity changes, obviously, is really the problem. It wasn't my fault. It was this different liquid. So yeah, so I think probably the easiest thing for us to start playing with then at this point is just maybe like working on some of these guys. I also feel like our familiar has stopped going because I don't know if we ever ported his code. So I feel like we could do some of that work. So maybe let's just go through and just tidy up some of this stuff, get everything ported, make sure we're working, and take a look at like the Monstar and the hit points and that sort of stuff. Because now that we've taken care of the sim region stuff and we've gotten that sort of in there situated, now might be a good time to kind of deal with some of this stuff. So let's see. Our familiar does not appear to be working properly as far as I can tell, because before our familiar would follow us around, and he's totally not following us around, right? Like he's not following us around at all. So why isn't he following us around? Let's take a look. So when we're in update familiar, and I guess I'll also take a look at the code that calls update familiar. So in update familiar, we're just getting normally called as I think we would, and we are passing a sim region entity in a time step. We then say that we're going to search within 10 meters. We go through here and we search for inside. Oh, well, that's pretty obvious. For some reason, we never incremented the test entity pointer. So we did port it. We just ported it badly. I'll go ahead and recompile that and see if the familiar, there we go. So we just weren't looking through all the entities. Simple bug, problem solved. All right, so there's our little familiar and off he goes. Makes sense. So let's take a look at the Monstar, and let's take a look at the collision detection and the sword and that sort of stuff. So it looks like, you know, we've got this non-spatial flag here, and I feel like for the most part, that doesn't really need to be, like, depending on how we decide to do things, we wouldn't really have to check for this at all, right? Because now, since we only pull things into the update region, if those things are actually, we only call the update function if something's actually inside the update region. If the sword is not inside the update region, it wouldn't get called. So, you know, this may not even need to exist anymore, right? If I were to get rid of this, I don't think it would matter anymore, because we sort of got rid of the need to even have that concept now, because since yes, they get brought into the simulation set, but the simulation set has a concept of updatable that doesn't include any entities that would have had non-spatial set. So that's kind of interesting. I wonder if that will allow us to simplify some things even further. I hadn't thought about that, but it's kind of interesting and kind of neat. So kind of an accidental thing that happened there, but you know, I'll take it. So when the sword moves, right, we're calling move entity on the sword. And what we want to do now is we want to figure out a way that we can sort of use our collision detection to actually do some kind of an operation when the sword hits something, right? And we talked a little bit about having a table that would record when things got hit and that sort of stuff. So let's go take a look at that stuff because we want to be able to do all that stuff. So we might as well just pick up where we left off way back when and actually start coding some of that. So we've got our move entity call, right? And the way the move entity call is it does the equations of motion for this thing. And you know what else I should probably do while we're at it, while we're just cleaning stuff up, because I'm thinking about it right now? We've got like this DZ update stuff. That should probably be inside move entity as well, right? It's like the move entity should update the Z coordinate, I feel like, for stuff like so. And so, you know, for now, I would say we should probably do this in here. Now, we probably want to integrate it in a little bit better than it's been integrated in right now. But let's just go ahead and put that there for now. And then that should allow us to have you know, our Z get handled along with everything else inside the move call, and that seems just better, right? So let's just do that, and that's done. So what I was going to say was when we do our move entity call, right, we're doing this test for collision, and you know, it's totally fine. We haven't really done a real one yet. It's not a really very it's not a complete collision detector, but it does let us know when things hit other things. And when things hit other things, we have the option of doing something about it. And obviously that's what we would want to do in the case of the sword. But what we have is we've got sort of our colliding flag doesn't really tell us everything that we might want to know about what we should do to handle the movement of this entity, because we really want two things for the entity as far as collision are concerned. We want to be able to do collisions, and we want to be able to respond to collisions, but those should be separate things. Some things, right, may want to actually stop when they hit things, right? Like we may want, you know, like for example, the reason we originally wrote this, when the hero hits a wall, we want him to stop moving. That's one thing we can do with collision. But another thing we might want to do with collision is allow the player to pass through the wall, but just, you know, do something about the fact that, right? So imagine not a wall, and instead this time it's a floor plate. We may want them to be able to walk over the floor plate, but we want to do something in the case where they have walked over it, right? So really we want to start breaking our collision response into multiple pieces, which is detecting the fact that it happened and responding to it are not going to be the same flag, or not even going to be the same like idea really. We want to separate those out into two different things, because the sword might be an object that works exactly like that. It may not stop when it hits a monster. It may, you know, pass through the monster and do damage, but do damage to other monsters as it goes, like perhaps it has piercing and that sort of stuff, right? So we want to be able to sort of have individual control over which one of those is going to happen. I did the drinking correctly that time. So, how do we want to do that? Well, it's pretty easy for us to do something very simple, right? And so the complicated part is actually going to come in how we sort of want to break this routine out into something that's a little more usable by the higher level code. And so we've got a couple different things to talk about here, all of which are very, very intricate and complicated. And so we might not do all of them right now, but we'll sort of talk about them. So the first thing that you'll notice is inside a single collision, inside a single move call, we have an iterative system that's working, right? And I'm going to go ahead here and draw this out for you, because it's been a while since we did this. I just want to make sure people remember. So let's say that we have, well, actually, I'll draw it a little bit differently. Let's say that we have something like this, right? Well, that's not what I really wanted. Oops, let's bring that back. Okay. So let's say that I have something where I've got a wall like this, and then I've got another wall like that, right? And the player is trying to move like this, okay? And so when they hit this wall here, we are stopping them, and that's good. But we're allowing them to continue to move along the wall, right? And what we're doing is we're saying, well, wherever you could have moved to if you had moved the regular direction you were going, will allow you to go that far along the wall, right? But the problem is there may be another wall, like in this case. So we would then do another collision step to find where you hit that wall, right? And so really there are two iterations inside a single call to move entity. In this case, we would have had two iterations, one that moves the guy to here and hit this entity, whatever this is, right? And another that moves it to here and hit this entity, which could technically be a different entity, right? So this could be entity A and this could be entity B. Now what we want to do, what we want to start doing here, like I was saying, is for entity A's collision, we may want to have a response, right? We may want to do something when A and whatever our entity that we're moving are, we'll call that E. When E and A collide, we may want to do something, right? And then furthermore, when E and B collide, we may want to do something. So we're now in a position where we have sort of this, this need to do a dispatch. But we need to do the dispatch from inside of an iteration, right? And so the normal way that people handle this is with a callback, right? What they do is they come in here, because this is the part of the code, excuse me, inside this iteration here. We would want to do this inside the iteration, right? So when we do hit entity, this right here, here is where we would process whatever the entity that was that you hit. Here's where we'd process it. So what they typically will do here is they do like something where we do like, you know, process collision, right? And they would call out into something that handles the collision. Now, I don't know if we necessarily want to do that, right? We might not. What I do know is that typically it can be a little bit annoying to have it work in a callback fashion, because a lot of times callbacks lose a certain degree of important flow control that you might want. Now, this is the first time that this has really come up, and so I think I'm going to spend a little bit of time talking about it because we do have plenty of time left and we don't have anything particular that we need to get done on the stream. So now might be a really good time to talk about this. So let's talk about it. So let's talk about callbacks, right? So basically what we have right now is we have a pretty nice system. We have a function that's called moveEntity, and anyone who wants to can call moveEntity to move their entity, right? And we can use that in any way that we want. There's no restrictions on what we can do with it, right? We can just do it, and if we have an entity that we want to move, we move it. If we don't, we don't, you know, and we can also call moveEntity multiple times if we wanted to on a single entity, or move different pieces of an entity with moveEntity. We could do all kinds of stuff, right? There's all kinds of things we could do with moveEntity. And the reason we can do that is specifically because it doesn't really do anything inside it except the one thing, right? All it does is it moves the entity to wherever it should have been, given the collision that's involved in the simulation region. So a callback introduces something into here that's, and this is true of any situation where you introduce callbacks. Any time that you have something that does an iteration, right? So typically there's some kind of complex iteration involved, right? And we saw the iteration, it's a collision iteration, but there's other iterations, like let's say that you had something like a binary tree, or you had something like a XML file, right? And you've written an iteration that iterates over it, but you want to do something on every node, or you want to do something when you find certain things, or you want to test it. Callbacks are a typical way that you introduce that functionality, because you can sort of pass the callback in, right, or something like that, to the function, and then the function will sort of do something, will call that and allow that to work. Now, other languages, and also in C++11, have slightly better versions of this, right? They have closures and lambdas, right? I don't know how you spell lambda. Lambda? Yeah. They have other things which allow you to access different stacks and kind of do some other things that make callbacks a little more painful. But the bottom line is callbacks are always kind of not really what you would prefer to have happen if you could have written the code to basically never have to share anything, right? And why is that? Well, the reason for that is actually pretty straightforward. If I have a piece of code, you know, if I have code A, right, and I wrote it, and then I have code B, and I write that, right? Code B is the thing that does the iteration. I want to be able to share, you know, with I got code C down here. I want to be able to share this iteration with both code A and code B. I'm sorry, and code C, right? I want to be able to share, should probably know over these bit. Let's call that B and that C, right? Or better yet, code S for shared. So I have code A and I have code B, and they both want to use code S, right? They want to use that iteration, but they want to do different things when the iteration happens, right? So the reason that callbacks are kind of a nasty way of doing this is it forces whoever wrote code A, right, to basically bundle up something that's capable of doing whatever it needs to have being done and send it over to code S, right? So that code S can actually do whatever the thing is that needs to be done. Now, it basically introduces this nasty coupling of the S code understanding the sorts of things you might want to do in A and B, right? And preparing it such that it can use whatever this black box is that's been passed. Furthermore, it assumes that code A has to be able to bundle up all the stuff it might want to do, which is kind of cumbersome for it, right? And it has to sort of have this sort of notion of context and all the things that it might want to do, bundle them all up and then send it over, right? Really for no reason. Because if we were only going to write one piece of code, let's say we just had code B and code S, right? BS. Okay, let's not say that. Let's say we had code A and S, right? Or I could do code SB, put them the other way around. So let's say we had codes S and B, and we were just writing, that's all we were writing. We never had to share it. Then what you would do is you'd just write the iteration code, right? You'd just write this, and then whatever this code that was going to do, whatever it was going to do, you'd put it right in here, and it could be made nice and clean and optimal, and everything would be great because everybody kind of knew exactly what was supposed to happen, and you didn't have to have this part where two sides of the program were written without knowing what the other person was doing or without being able to really change what the other person was doing, and that's where you get sort of this callback nastiness comes in. So again, these things make them a little bit easier because you can share stack frames or some stuff that you can do in languages that support other things. And again, C++11 adds these guys, I believe. I don't think it adds these. I don't really know. I don't stay up to date with C++11 much, but pretty sure they add the lambdas. We'll put it that way. And so really, if you can avoid it, though, it's nicer if you can get out of this business altogether and just allow whatever this was that you were going to write in here, this S code, the thing that does the iteration. It's oftentimes much nicer if you can just expose that as a sort of tool that these guys can use to write an iteration, right? So basically, whatever this was doing, if you can package it up as an iterator that these guys can use, then you are able to sort of reverse that flow instead of having to pass this into here. If you can just fragment this iteration code up into basically two parts, right? The initialization and the stepping through the iteration. If you can break that up, that gives you a lot more flexibility to write the code on the outside any way that you wanted to without having to deal with this sort of black box passing kind of nonsense that's just, makes life a little more difficult for everybody. And so what I would probably recommend doing, depending on how we decide to go forwards with this, and I'm not sure exactly how we will decide to tackle it, is if we decided to keep calling move entity the way we've been calling it, I would probably go ahead and break this iteration out into its preamble. So I just take this portion here, break that out into something that basically sets up a struct that has these variables in it, right? And then I would have an iteration call which does this stuff. And that call would just return the hit entity. And you could call it as many times as you want, and then when you were done, you would say finish, right? And it would do this postamble. That'd be a really much cleaner way than like introducing a callback in here that does the collision on the times when that happens, right? So that's one way I could go. I'm just trying to give you the full what's in my head when I'm thinking about this. So that's one way I could go. And I'm totally fine with that. That seems like a good way to go. But there's another way I could go, which is if moving entities is something that's always going to be handled in a central local, like a central logical fashion. So basically, moving entities just isn't something that's allowed to be done pretty much ever, except by the centralized concept of the update. Then what I could do is totally change how this works entirely and say, when you do your update call, you are not allowed to move your entity. You don't get to call move entity. What you do is you latch in what you want your acceleration to be, because that's what your control is, right? You get to set your acceleration, and then once you've set it, the movement will happen automatically somewhere down the line, right? So that's another way I could go. And if that's the way I could go, then this doesn't become a callback situation because there's only one thing that can ever happen in here, which is this is the place where dispatching entity collisions actually gets processed, but it's always going to be processed exactly the same way, so we don't have a situation where we've got to hoist that out. Now, to me, just on the whole, that kind of sounds like the right way to go. And the reason that I think that kind of sounds like the right way to go is because in the future, we don't know exactly how we might want to do our actual updating. We might want to try and do some simultaneous collision solving where like multiple people are moving at the same time and we find their intersection points, that sort of stuff. Who knows what we may want to do. And so what I probably don't want to do going down, what I probably don't want to establish as an early on policy at this point is the concept that entities all call move entity themselves. I think I might want to take that out of their hands and say spatialness is just an inherent aspect of gaming. We will handle it in a centralized fashion. You aren't really going to do that, right? So we're going to do that for you. And basically, like, we'll just have a flag, an entity flag, which says, I am an entity that can move or something. And that, or, maybe you don't even have to have a flag. It's just if acceleration was set, then it goes, right? And to me, just thinking it through, I feel like that just feels a little bit better to me. It feels a little bit more like probably what should happen. So I think that's what I'm going to start with. And then if it turns out that that doesn't work, then we'll sort of address it a little bit further on. So for now, I think that's what I'll do. What we'll sort of say here is maybe we'll just say when we're doing our entity update for now, again, this not at all set in stone. What we'll kind of do is say, let's set this move spec and this DDP here. Let's go ahead and say that those are going to be things that are sort of set in the entity's update, and then the actual movement call is not something that the entity actually gets to deal with. That's something that happens somewhere down the line. So like this stuff right here, that doesn't get to happen. Instead, what happens is this move spec up here, right? We'll set that to the default move spec for now, like so. And then the move spec will get set in here for each individual entity, and then this doesn't actually get to happen. So the con hero DDP, excuse me, becomes that DDP, right? So this starts out with no acceleration. The con hero DDP, that gets put in there. Actually, I guess, and the entity DZ would also be that as well. I would say, no, that's discontinuous, so that's fine. All right, we'll talk about that later, because this is our stupid jump code that shouldn't even be in here. But yeah, it's lingering. So instead of calling move entity, that move entity call will get pushed out to the bottom, right? We do that here. And what we're going to do is we're going to say that this right here just sets what we want the acceleration to be, and that's it, right? Similarly, the rest of these guys don't get to do that either. They all have to do the exact same thing. And I'm also wondering why we even bother having these. I don't know why I have like these calls separated out. These seem like kind of useless functions to me. These should just be inside the switch statement. And this switch statement should be out here in the handmade entity. But, what are you going to do? Sometimes, you can't win them all. We'll think about how that's structured a little bit later on. So what we want to do here is, we want to be able to sort of have this worked out. And maybe, what I could do too, I could sort of say that move spec, nah, I'm not going to do that. All right, so when I update the familiar, it wants to be able to set a move spec as well. And it's going to have to set its DDP as well. So I need a convenient way, for as long as I am keeping these guys out here. And you can see why I don't love having these out in separate functions for no apparent reason. I can't just go ahead and set these things that I want to set, which is kind of annoying. So I might just go ahead and just stick this in here. Let's go ahead and say that we're going to go ahead and, there we go. So now I can just set my move spec directly. I can set my DDP directly. Of course, swords don't have a DDP. We can get rid of these guys. That's gone. We can get rid of this. That's gone. So let's see. Update familiar. There we go. Goodbye. And that actually makes this a lot nicer to work with. And then I just go ahead and pull this out, and this would be the routine that basically holds all of our update calls. Again, a lot of people are always like, oh, you got to pull it out into a function, but there's no difference between a function and just a case statement, right? You still have a file that lists all these things, right? Whether they're functions or inside a switch statement. But if you put them inside a switch statement, you have the option of having the preamble stack be shared, which is just so much nicer to work with, right? Yeah, so I don't tend to agree with people who want that, you know? It often just seems like a really bad idea. But, you know, I guess everyone has their preferences, so what are you going to do? So I guess what I'll do is, yeah, I'm just going to go ahead and pull this out. I'm going to put these things in there, and then I'm going to pull it out so that all of our entity update is just in one file, and it's basically a set of case statements, one for each guy for now. That's probably not how we'll do it eventually, because I've got sort of bigger plans for how I want entities to be composed, but that's a separate issue. All right, so now that this guy's in here, we can just have the move spec be set directly, and the DDP will also be set directly. In fact, we can just delete that, and now it works exactly as we thought it would, I believe. Let's go ahead and compile that. Process collision, that's not a real thing. Let's see, more than one. Oh, handmade entity. Let's get rid of that. Con hero. Okay, so now we need to do our actual call. We've got the sim range and the entity. We've got our DT for frame. We've got the move spec, and so now we just need to change that to the regular DDP, and then I think we're good to go, right? Am I right about that? Ooh, what happened there? Move entity, non-spatial. Ah, right, forgot about that. So what we do have to do here as well is we have to make sure that we're actually only moving people who should be moved, which actually is not too onerous, because really that's just if DDPX or DDPY, right? If there was actually any movement that someone actually wanted, that should be sufficient to tell us, right? Yes, I think so. That would be my assumption, yeah. And that does look like, ooh, what's happening there? What's going on there? I've got something. There we go. That should not be happening. DT move spec. Oh, and you know what too? It's actually whether their velocity is there. That's right. It's whether they have velocity or they have acceleration, not just whether they have acceleration. Although really, again, like I don't know if maybe we should have something. This is a little bit of a weird way to see whether an entity should be movable or not. We might want something a little smarter than that, but I don't know. For now, I suppose it's okay. We'll see. Got to get a little further down the line. So that's a little weird. That guy doesn't look like we had, for our sword there, it didn't look like our sword was properly using its distance remaining. Let's see here. So if it's just make entity non-spatial. So yeah, we also, now that I think about it, once something gets made non-spatial, this would move them back into spatialness, so that's probably not good either. So we may still need to check that. Now I think so. Basically, we may have to actually just say that we're going to still have a check on the flags there, and then only spatial things will actually get to do that. So we'll do that. We'll do if is set entity non-spatial, right? Then it can go ahead and do its move. Let me see if that's a little more sensible. I still don't understand why this guy can go forever though. That doesn't make a whole lot of sense for me. Shouldn't his distance, I guess I must have, when I cut and pasted the code in there, I must have not updated everything. Distance traveled equals the entity P, oh right, because now since we moved, we were counting on the fact that we knew how far it had moved since the last frame, but now we don't actually know that anymore. So that is the one place where we were counting on the fact that, so far anyway, that an entity would actually get information about that. But we already had a bug of that form, which was that we essentially didn't handle the fact that inside a move, it shouldn't have been able to be allowed to move further than when the distance traveled timer would have happened. So what we really probably want to do is handle this in a more robust way where the collision routines actually understand the concept of a limit to the motion and will stop it at that limit. So I'm going to go ahead and say that that's something we can do tomorrow, and this will be our important to do for tomorrow. Add the ability in the collision routines to understand a movement limit for you know, for an entity, and then update this routine to use that to know when to kill the sword. Yeah, because that was a bug we already had. That's this to do down here, right? And so we kind of want to go ahead and actually fix that so that it's not going to do it that way anymore. And that's what we'll start with tomorrow. And then we can also finish our collision stuff. Figure out how we want to do that. We'll move this guy out as well. I think I want to put the to-do in here. Move this out into handmade entity.cpp. And then that way we'll have a special place where all of our entity updates live, just so they're easy to spot and understand. All right, so that's about it. We can go ahead and go to the Q&A. I don't know how it's been going over there on the chat, but I guess now we will find out. Please prefix your colons. Please prefix your questions with Q colon, or prefix your colons with Q, your choice. Yeah, well, actually, I guess you have to prefix your questions with Q colon if you want me to see them. And please keep them to stuff that we did on today's stream or on a previous stream. If you want to ask off-topic questions, do that during the pre-stream. Just come 15 minutes before any scheduled start time, and we take off-topic questions then. Handmade here. How will collision be done with moving backgrounds, such as mazes and moving tiles, or that won't be in this game? Actually, so the code already works with that. I guess I don't know that we have any way to demonstrate it right now, but I suppose what we could do if we wanted to, right, so here's what I'd say. So right now we know when that happens, we just don't do anything about it, and that's something we need to do anyway for other reasons, just for collision robustness, because right now we would get into situations because of floating pointness where you could get stuck in an entity, right? Because we don't handle, like, I can't quite demo it right now. There you go. I've got it now, right? Where you can get locked in an entity, because floating point precision wise, when we do our collision detection, we don't try to ensure that we actually put you outside of things. And if you don't do that, you will always get into situations where you get like janky collision behavior. Once we add the code to do that, it will be pretty easy for us to handle moving backgrounds, because we already support collision detecting with moving backgrounds. That would already work. The problem right now is we just don't respond to them. So when they hit you, they would stop instead of you getting pushed, which is probably what you wanted. And so as our collision routines become more sophisticated, we should just, the moving background stuff should just work. It's not very hard to handle, but that's really the problem right now. Detection is easy, but handling it, we haven't done yet. So we would need to do something that just, when two objects collide, we just need a notion that one of them would take priority. So when that background object hits you, we just need some kind of a notion that says it has the right of way, so it will push you, right? And we should be able to handle that pretty easily. There are a bunch of things you have to watch out for when you do support that, like what do you want to do if somebody is like pushing, if a pushing object pushes you up against something, what do you want to do? Does it lock up? Does it stop at that point and you can scoot out of it, or who knows what happens exactly? But those are the kinds of things that we have to decide, probably more based on gameplay, like what we want to have happen. So it is a little bit of work to handle those things, but it's not like the end of the world, especially since the bar is pretty low. Like most games kind of flail pretty miserably at handling a lot of those things. You always see all these weird bugs and stuff, but we should be able to do a pretty good job of handling that once we get there. Why don't we use C instead of CPP? Because we do use we try not to use too much random C++ness because I'm not fond of it. But we do. It actually is not C. It's actually C++. So you can see, for example, you know, that would not compile in C. So we do use some C++, just not very much. That's a good question. Someone just asked, when I started enums, why did I start with 1 shifted up 1 instead of 1 shifted up 0? Because I was not paying attention. There's no reason. That could totally just be that. Yeah, that just totally asleep at the switch. How big are the source files getting? Are you feeling overwhelmed by the size yet? Whoa. Overwhelmed by the size of the source code as it currently stands? This source code's like wicked tiny, isn't it? I don't know if is there a lines counting? Oops. Lines? Block? Do we have any line counting program? We don't have a line counting program. Count lines. Region. So if I select this whole thing and do count lines region, oh, well, I guess it says at the bottom, 117, 428. I don't know. We'll have to download something that counts lines so we can actually see how many there are. But I mean, just looking at the size of the code, just even ignoring the line count. But I mean, look at there's nothing here. It's like 150K a code or something. Like, it's hard. There's like no code here. This is like so tiny. And like a huge portion of that is the random number table, right? And the Win32 platform code. So there's like hardly no code at all. This is so tiny. What happens when you somehow glitch through a wall? Will the game crash? It certainly wouldn't crash. You'd just get stuck in the wall. At the moment, you mean? Like, I mean, obviously, in the final version of our stuff, we won't allow you to glitch through a wall. At the moment, nothing would happen other than you getting stuck behind the wall. But you could probably try to glitch your way through the wall again, I suppose. Oh no, heavy moderation tonight? I'm sorry about that, guys. Do we need more moderators? Maybe we need more moderators. I don't want you guys to be too swamped. If you need more help, let me know who you would like me to add. How many lines have you written so far? Yeah, I don't know. That's the thing. We need like a line counting program. I'll look one up. There isn't one on this machine, I don't think. So yeah, I don't know at the moment, but not many. I mean, like I said, this is very tiny for me. This is not a lot of code. In what situation would you prefer callbacks to a huge switch case block? I can't think of any offhand. There probably is a time. I just can't think of it offhand. Switch case blocks are almost always far superior to callbacks, in my experience. They're better in almost every way you can possibly measure in terms of code quality, like in terms of like flexibility of the code, ease of reading, ease of use, ease of compression. Like, they're better for just about everything. But there may be some things, I'm trying to think if there's some things. So one place where I can think, just trying to think, where you might have a problem with them is like if you're trying to isolate platforms from each other. Like, you don't want your Win32 code and your Apple, Mac OS X code and stuff intermingling, then that's a place where you would want to keep those files segregated, right? And you wouldn't be mixing things in with a switch statement. So, I don't know, something like that. I tend to always architect those so the platform layer stuff flows forward, but we've already got like an example of a callback in there for the debug loader code, so that's an example. But yeah, it's not often. I don't, I think, I'm still sick, by the way. So there's a little bit of nose blowing going on. Basically, my opinion on switch statements is that somewhere around the object-oriented apocalypse, in the 90s, everyone kind of got it in their head that, like, for some reason, like, objects and inheritance and virtual functions and all this are, like, a good idea. And switch statements got this sort of bad rap. But the opposite is really true. Like, the switch statement is the superior method of those two. And so almost every place that people use, like, a virtual function, they should be using a switch statement, in my opinion. And, object-oriented programmers will get mad at me for saying that, but I have written the code both ways, and I am totally happy to go to the mattresses on that one because it's just true. Like, it is far superior code in a switch statement. There's so much more stuff you can do with a switch statement than you can do with virtual function calls, and virtual function calls are almost always worse, right? And the list of things is non-trivial. To give just a couple examples, but like there's the preamble, postamble stuff that's really easy to see and understand in a switch statement, right? It's not in some weird inheritance hierarchy where the person who's adding a new virtual function doesn't even know like what things might happen pre and postamble and all that stuff, or they can just see it. They can access the variables directly inside their thing in the pre and postamble without having to know where to look for them or to get them from some extra thing. The switch statement switches off of a value, and that value can be persisted, whereas a virtual function cannot be, for example, right? Like, there's no way to persist the type of a class automatically in C++. You have to introduce a secondary scheme, which, guess what? Ends up being an enum. You could have just switched off that enum instead of introducing a virtual function table for no reason, right? It goes and goes and goes. There's never... It's all bad with like virtual functions and that sort of stuff and function pointers. They're just always worse than switch statements. But I shouldn't say that. They're almost always worse. But there are a couple times, I mean, I'm sure if I go through my code, I can find places where I've used function callbacks. I never use virtual functions, but I might use like a function call or a callback for a legitimate purpose. One is platform code stuff, where you're trying to keep the code out of a thing. I'm trying to think if there's other cases. There might be a couple I'm forgetting. So always is the wrong term. I don't mean that, but almost always you should have written a switch statement. Do we load and draw everything manually to a div section, then blit the final image? Yes, that is correct. The way we handle GDI drawing is basically we try to do the minimum amount of cruft between the two. So we just we don't even really use a div section technically. We just use a buffer of bits, and then we ask GDI to put that buffer of bits to a window, please, so we can see it. After you mentioned the do all collisions at one time thing, it seems like in addition to being a great deal easier to implement, it also matches the real world better, like summing all the forces to get the net direction. Why would anyone ever want to do an update function for each object? It seems like that would just introduce problems. Well, yeah, I mean, I think most of the time people do it the way that I'm suggesting we do it, but, you know, I mean, it's 6 of one, half dozen of the other. I mean, there's reasons why, like you saw how we had one example, right, that is harder. If the object's custom code can't control when it does its update, it can't do things like look at its previous and last thing cleanly. Now that has to be something that gets hoisted out, right? There's reasons why it's more convenient for the object to be able to say when it gets updated. In a perfect world, you'd have it so that you could probably do both things. Like it gives the pre and post amble in a still clean fashion. Like this is probably something like John Blow's language will let you do. Write it as if you did it this way, but then pull it out so that it ends up running it the other way, which would be kind of cool. But yeah, so, but no, I mean, it's true. Like you say, the reason I'm suggesting it, because it's, you know, it is a common way to do it. It's not, I'm not suggesting some really radical new thing. That's a common way that people implement their engines. And I suspect it's probably the right thing for us to do, but, you know. I use clock to count lines. It is pretty decent, says Jonathan Blow. I don't know. Can we get that? Clock. Download. There we go. I'm looking for the latest version. Is it downloading? Yes. Your download will start in 0. So why didn't you just download? Because you wanted me to watch your ads. Of course. Maybe SourceForge will tell us what the latest flavor of Mountain Dew is, since I don't have an Xbox One. Okay. So there we go. So if I actually start up downloads, there's clock. So I will go ahead and put that. I guess I don't know where I'll put that. I guess for now I'll stick it in W, because I don't have a better place to put it. There we go. This doesn't require an install, does it? Or does it? Run. No, it doesn't, so that's good. So we'll just call that clock, and I'll figure out where to put it later. But now we can run the code. So it looks like this is all code in here. This is all of our code, I believe. So if I just run clock on the code, can I just do star? There we go. So yeah, so 4,000 lines of code, right? That is, assuming that I'm reading that properly. So that's like really tiny, I feel like. I don't know. I just don't feel like that's very much code to keep in your head. It seems pretty straightforward, unless I'm missing it. So yeah, so there you go. And if you add them all up, you know, it's what, something like 6,000 lines of code. I don't know. It's not very many lines of code. A bit off topic, besides the bits that are obviously tacked on, would you consider the Windows GUI a good API? Parts of it seem pretty intuitive and clean and clear, but I don't have much to compare it with. So I don't consider that off topic because we've done Win32 programming on the stream a bunch. So talking about that API is totally reasonable. I guess what I would say is Win32, the C API for Win32, isn't bad, but it's not good. Like the original Win32 API is okay. There's a lot of things that I wouldn't have done the way that they did it, but it's not horrid. The stuff they've done since then is mostly horrid. Like most of the newer stuff as it's gone, like if you actually were to program the Windows API the way they want you to today, it's an epic disaster. So I think to really answer that question, you'd have to specifically talk about a particular part of the API and say, is this part good? And then you could say about the pros and cons of it, because it really does. It's very, very. Microsoft's a giant company, right? And the API was not designed by one guy. It's been designed by hundreds of people by committee now over many years, and it's in many different parts. And so it's really hard, to take a particular piece and say, or it's really hard without taking a particular piece to say good, bad, ugly. Becker 929. I guess I should have asked how big it has to get for you to start feeling overwhelmed. Probably like 100 times that size, I would say. I would expect to be at like 400,000 lines before I'd start to be feeling like I had no idea what was going on, probably, would be my guess. I think 10 times this size would still be pretty easy to manage. Like 40,000 lines doesn't sound like a lot. 400,000 lines might be pretty big. I don't know. I don't think we'd get there. Programming only an hour a day, I don't think we'd probably get there. So 40,000 lines might happen, depending on our speed in sort of the later times when I'm explaining less and typing more. How did you decide on this order to build up the engine? Was it intuition or experience? Well, again, I think I've tried to kind of show how that goes as reasonably as I can. Obviously, there's some degree of experience in there that you just can't avoid, right? And I'd be lying if I said that the experience isn't a huge part of it. But what I have tried to do for the most part is show you how you can sort of muddle through something like this by always taking the next logical step, right? And that's what I've tried to do. I haven't tried to make any giant leaps. I've always said, let's try to do X, and then we kind of work towards that, and we see what falls out of it. And you'll note that, like, I started off, I just made a simple tile map, right? And we sort of saw how that was going to go, and then I said, oh, well, we want to be able to make it so that it can be infinitely huge. Well, not infinitely, but very, very large, so we can't just use floats, so how are we going to do that? And we did that, and I was like, well, okay. I don't really want these things to have to be on tile boundaries, so let's try getting rid of that. And then I was like, all right, I don't like how this is going. Let's try to make a system so that we can actually make it so that we don't have to work on using the weird positional stuff. And I want to scale the number of entities up, so we did that. And we've kept just doing, like, what's the next thing we want to do? Let's write some code, let's see how it goes. And we've been letting the engine architecture emerge out of that, which is the whole point of this first 100 days, let's say. Which each day maps to roughly an hour. So 100 hours isn't much time to spend on a project, right? 100 hours, if you work a 40-hour week, 100 hours is a little more than 2 weeks of full-time work, right? So spending 100 hours on figuring out what your architecture should be is cheap. And so in the scope of a whole project. And so the reason that I'm approaching it this way and encouraging other people to approach it this way is because I think it's really valuable to spend the time just writing the code, seeing how it works, and then letting that architecture emerge, and so that when you actually go to do the final component, like when we want to go do the final collision detector, when we want to go do the final renderer, when we want to do whatever, we're not just designing in a vacuum, which is where bad designs come from, right? Instead, we're not even really designing at that point, we're just programming, because the design was already there. It already exposed itself by us sort of drilling at it. It's sort of like sculpting, right? We chiseled away and chiseled away and chiseled away, and then we were left with something that was like, yes, this is the piece. Now we just have to go do the detail work, right? And that's way better than trying to do it the other way around, where you just like sculpt each part totally separately and then bring them together and hope that they form a sculpture, and then they don't, and you're like, this piece doesn't fit, and what are we going to do now? Get the glue out, right? And it's like a disaster. And so, I'm just kind of, that's the way I've been doing this. And again, I do have a lot of experience programming, that is true, but I don't have a lot of experience programming 2D games. Like, it's not something I do. I don't program 2D games for a living. Like this kind of game, like Zelda-y games, I've never written one before, right? That's not what I do. And so it is true that I have a lot of experience programming. It's not true that I have a lot of experience with certain aspects of this development. And so I've been trying to do those things exactly the way I would go and discover them if I were doing it in a regular professional setting, so that you can see how I approach that problem and arrive at good solutions. Because as much as anything, that's the most important thing to learn, is how to tackle a new problem and arrive at a good solution. And it takes hard work and it takes effort, but most of all, it takes the right approach. And I really do think that approach is exactly what we've been doing. Write the most obvious thing you can first, pick a goal, write the most obvious code, see what it looks like, what doesn't work, get a little bigger, right? Keep picking new goals and pushing that code outward. And then you can sort of see the things start to form in there and pull them out as they become obvious, rather than trying to guess ahead of time how to do everything, which in my experience just does not lead anywhere good. Oftentimes, no matter how much experience you have, because the only time that really works is if you've done exactly the same thing as you're already doing. But most of the time, that's not that interesting. Most of the time, you want to be writing things that you've never written before. You want to make new things that people haven't done, right? And so that's how you do that. Speaking of UML and diagrams, you ever use class 1 schematics for code planning? No, I never do that. That is not something I would recommend. I feel like diagrams pretty much leave out the important parts of code, the complexity of code, and so they tend to not be very useful. I always say start with the code and abstract upwards from it. Don't you need to be able to enumerate every possibility in order to use a switch statement? What if you want to make a system that can be extended? Well, extended in what way is the question, right? So if you're talking about extended as in people adding stuff to it, well, they just add to the switch statement, right? That's not hard. And you can even do that if you want to by making separate files. Like you can use the pound include in there if you want for some reason, but I wouldn't do that. I just put it in the switch statement. If you're talking about you want things to be extensible outside of changing the code, well, at that point, you've got to have scripting languages or something like that anyway, right? So because if people are loading code dynamically, you've got to have something that allows that to actually work, like a DLL or something like that. And if that's the case, it's still not that big of a deal, right? You can still do most of the same stuff as you would do with a switch statement, but unfortunately, if you go that route, you give up kind of one nice thing, which is the ability to have the preamble, postamble stuff be directly accessible by the things in the switch statement. So you lose one thing if you do that. But other than that, you can still do it basically the same way. People just have sub-switch statements, right? They basically make their own switch statements, and you're calling each of them or whatever, but I don't know. I think most of the time, if you're talking about stuff that's extensible in a game, you're talking about a switch, having to have a scripting language, because if you want players to be able to quickly and easily modify stuff, they're probably not going to want to be using your C++ code or whatever, right? I don't know. I mean, so the answer to that question is I can't really give a total answer unless you can tell me a little bit more about what you mean by extended in the case of this type of code. Why use switch statements instead of just big if-else blocks? Yeah, if-else blocks are fine too. Either way, I use switch statements because they're less typing. Will the way in which collisions are handled be order independent? I don't know yet. That's a good question, and I don't know. I suspect probably not, because I don't know that we have anything in the game. I don't know that a Zelda game tends to have a lot of reasons why order-independent collision is important. So I guess what I would say to that is probably not, unless we find some reason why it should be. And maybe as we get through further along in the game, we will find a good reason why we have to make sure that it's order independent, and then we would. But otherwise, I don't think we would introduce that complexity unless I had a reason why I thought we could use it for something. Is it better to debug as you go or towards the end of a programming cycle? So I would say that personally, I don't think there should ever be bugs in the code that you know about, right? Like, for the most part, I always try to debug a bug that I see when I see it. I don't leave bugs in the code unless it's a case of like, oh, that's the case of a bug in the sense that I know that there's a big thing that needs to get implemented in order to fix some problematic behavior, and I don't have time to do that right now because I have other things I got to do. And this is like a several-day task or something, which, you know, we've done on the stream before. It's like, oh, I don't like the way this is working, but I can't do it right now, so we'll, you know, kind of put it off a little bit. But in terms of bugs, like if there's just a bug, like I don't know what's going on, there's just something broken in the code, I always fix that right away. Like when you see it, the instant you see it should be when you fix it. That's the way I look at it. And the reason that I do things that way is because I feel like first of all, it makes it easier to write whatever code you were going to write, because now you don't have to worry about the fact that you've got a bug in there and who knows what the bug is from, and maybe whatever is causing that bug would also cause you problems of whatever you were going to write. So it may compound the difficulty of writing whatever it is that you're going to write, right? And similarly, I think it may lead to less buggy code at the end, because if you debug all bugs when you find them, there's no chance that whatever you're doing is going to mask some bug that you did see and now won't see later because you changed something and now whatever the bug was that was exposed has been hidden, right? So if you are ever fortunate enough to be able to find a bug that you can reproduce when you are coding, you should debug it at that time, I think. That seems to be the best way to go about it, in my opinion. Actually, you want to pass --no3, otherwise it is lying about the number of lines. It is dumb. --no3. Whoa. What is --no3? That does not seem to be understood at the moment. You will have to, John, you'll have to send me how to use this thing. Because I don't, there's --3, but not --no3. Oh, wait. Oh, it's just because I didn't pass. There we go. Okay, sorry. I'm dumb. That's the same. Isn't that the same? Is that the same though? That's the same. That looks the same to me. Did it change something? I don't know. But if you send me an email and let me know, I'll run it differently. Yeah, I've obviously never used it before until you just said it, so I don't know. Will the game have multiplayer and/or co-op? So we're allowing multiple player-controlled entities in the engine. So in that sense, it allows multiplayer, but we just don't know. The game design, I don't really know if we'll support it. So it will. The engine will support it, but I don't know if the game design will support it, if that makes sense. So we're going to allow, for the entire duration of development, multiple players to play. But the game design may not be such so that that actually works in terms of when we release the game. That may be turned off for the release because it may just not be a fun, there may not be a way to really play it with multiple players that doesn't break the game. So we want to support it in the engine just so we can show how to make sure that you don't tie things to just the concept of one player exactly. But I don't know if that'll actually be in there at the final game. All right, I think we are out of time. We have run out of time. So I'm going to go ahead and close things up. Assuming that I don't know, maybe did we run clock correctly? I don't know if we ran clock correctly or not. But 4092 is actually a power of 2. So I feel like that's a good number of lines to go out on. You're right that it did change slightly, right? So that's kind of weird in some sense. Yeah, that is kind of weird. Kind of weird. And I felt like that number was different before. What's the deal here? I'm getting a little weirded out, John. How come it said 69? Oh, that's the lines per second. Okay. That's just its speed. That just wants to let you know how fast it is with its line counting. Okay. So that has no bearing on anything. All right. So that's the same number. So I think the no 3 was not necessary for whatever we were doing. It seems like it did the same thing, but either way. All right, so let's go ahead and wind things up here. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure programming with you, as always. If you would like to follow along at home with the source code, you can do that by pre-ordering the game. You can do that on handmadehero.org. If you hit the little pre-order button, it comes with the source code, and every night I upload the new source code that we do on the stream so you can download it and follow along. Also, if you want to support the video series, we do have a Patreon you can subscribe to. If you are trying to catch up on old episodes or ask questions about things that you saw on tonight's program, we do have a news and forum site you can go to with a lot of great research on it. It also has ports that community members have done to Mac and Linux and that sort of thing already. So even though we haven't gotten to those ports on the stream, if you are trying to follow along on a Mac or on a Linux machine, that's a good place to do it. There's also now people have ported to iOS and Android as well, although I don't know how far along those ports are, but they're at least nominally working. So that's kind of cool too. So check that out. And finally, we do have a tweet bot. If you do want to know what the schedule is, you can subscribe to that tweet bot or follow the tweet bot or whatever it is, and it will tweet the schedule at you and let you know when we are here. Tomorrow night, we will be back at 8 p.m. Pacific Standard Time, same time as tonight. So if you would like to come back and join us for that, I guess tomorrow we will start looking at how to do, well, we have that to do that we put in there just tonight, and then we also have looking at the collision detection and how we want to sort of do that so we can start actually having some more entity interactions, like hitting people and taking damage, that sort of stuff. So I hope you'll come back and join me for that. And until then, have a good Wednesday, and I will see you tomorrow.